Hi, this is Physics Unit 1, October 2017. Question 1. Which of the following SI units is only used with a vector quantity? So option A says S, so S is time in seconds. Time is a scalar quantity, so it is not the answer. So a scalar quantity is one that has magnitude but does not have any direction, and a vector quantity is one that has both magnitude and direction. Magnitude is just a value. So for seconds, there can be 1 second or 2 second or 50 or 100 or so on, but it does not have any direction. It only has a value, a magnitude. So option A is not the answer. Option B is meter cube. So meter cube is actually volume. So a volume also does not have any direction. Option C is meter per second. It is also not a scalar quantity. It is a scalar quantity. It is not a vector quantity. It is a scalar quantity because we have velocity. It is meter per second, right? So meter per second is scalar quantity. So meter per second is speed. So speed is equals to distance by time, right? So this distance is scalar and this is also scalar, so this speed will be scalar. So option C is not the correct answer. Option D is meter per second square. So meter per second square is acceleration. Acceleration is a vector quantity since it has both magnitude and direction, and there is another way we can prove it, which is we have Newton's first law, F equals to ma. M is mass, F is resultant force, and A is acceleration. So mass is scalar and force is vector. So for the left hand side it is a vector, so the right hand side should also be a vector. So in this way we can say that acceleration is a vector quantity. So the answer to this question is D. Question 2. An athlete runs a race around half of a circular track of radius 30 centimeter. So this is radius of 30 centimeter using the inside lane. So this is the lane, this is the outside lane, and this is the inside lane. Using the inside lane, it starts and goes up to the finish line here. So at the end of the race, what is the magnitude of the displacement of the athlete from the starting point? So there are two quantities to be discussed, which is distance and displacement. So distance is basically the magnitude of length covered. For example, a person moves from here to here, and then from this point to this point, and then from this point to this point. So he travels A, B, C. So the distance traveled would be A plus B plus C, but the displacement would be this length, D. So displacement is basically the shortest distance. So the displacement is equals to D, and the distance is equals to A plus B plus C. So displacement is basically the shortest distance. So from here to here we will have to calculate this distance. So this is the radius, which is 30 centimeter, and this is basically the diameter. So 2 into radius is basically the diameter. So diameter equals to 2 into 30, which is 60, and it is in meter, so 60 meter. So the answer to this question is B. Question 3. A ball of mass 0.040 kg is dropped from a height of 1.5 meter. What is the kinetic energy of the ball just before it hits the ground? So the formula for kinetic energy is Ke equals to half mv squared. So kinetic energy is equals to half into mass of the ball into velocity squared. So we have the mass and we have height, so we do not have the velocity. But there is another knowledge that we can use, is that let us consider that this is the ground and we have the ball here, and the distance between the ground and the ball is 1.5 meter. So when the ball is at this level, from this level of the ground, there is a gravitational potential energy. It has the potential energy of a certain value, and when this ball moves to this ground, the potential energy, the total gravitational potential energy, gets converted into kinetic energy. So at the level of the ground, just before it hits the ground, the Ke is basically equals to the GPE. The kinetic energy is equals to the gravitational potential energy. So the formula of gravitational potential energy GPE is equals to m into g into h. So the value of m is 0.040 into g is 9.8 into height is 1.5. So the answer comes as 0.59 joules. So the answer to this question is D. Number 4. An object is dropped from rest in a vacuum. Which of the following is the correct graph of velocity against displacement for the motion of the object? So when the object is falling down due to gravity, the the gravitational potential energy is being converted into kinetic energy. So at that point, when gravitational potential energy GPE is equals to KE, we can also write that mgh is equals to half mv squared. And since it is talking about displacement and it is talking about velocity, we can also say that the displacement is actually the height. So m into g into d is equals to, d is the displacement, half mv squared. If we compare these two, we will get is d is equals to v square. So d is actually proportional to v square. So this means that for a value, if we take a value of v of 1, this is v and this is d. If we take a value of 1, the d will be 1. If we take a value of 2 for v, the value of d will be 4. If we take the value of v as 3, the distance will be 9. So we can see that for each increment of v, there is a greater increment in d. So if we plot the graph, for each increment of v, there is greater increment of d. So the answer is C, since if we take a look at this graph, for each increment of v, if we look at this, for each increment of v, there is greater increment of s here. This length is far smaller than this length. So the answer to this question is C. Number 5. As raindrop falls, they reach a terminal velocity. So a terminal velocity is basically a situation where the rate of increase of velocity starts to decrease and decrease till a point that the velocity is not changing anymore and it is constant. So it happens when, for example, when the raindrop is falling initially, no air resistance acts on it, and as it gains speed, the air resistance starts to increase. It increases and increases as the speed increases till a point that the weight of the raindrop. So if we draw a free body force diagram, this is the weight and this is the air resistance or drag. So till a point, the drag becomes equal to the weight, and thus the terminal velocity is reached. So which of the following properties has a negligible effect on the terminal velocity of a raindrop? So a raindrop is the water, right? So the water is falling down and the air resistance is caused by the air. So which of the following properties has a negligible effect? So let's see. Option A says density of water. So when there is a higher density of water, there will be a higher weight. Since there is a higher weight, there has to be a higher drag force. and since the drag increases when the speed increases or the velocity increases, so with a higher density of water there will be a higher weight, since density equals to mass by volume, so there will be a higher mass if there is a higher density. So density equals to mass by volume for a constant volume. Since the density increases, the mass increases, and since W equals to mg, since m increases, W increases, so since this W increases, there has to be a higher drag to reach the terminal velocity. So due to a higher density of water there will be a higher terminal velocity, so it has an effect. Part B says that the viscosity of air. So the viscosity of air is not correct, because you know has an effect, because as if an air has a higher viscosity, it means that it causes a higher resistance. So if it causes a higher resistance, the raindrop would reach the terminal velocity at a lower velocity if it has a higher viscosity of air, since with each increase in speed there will be a higher increase in the drag. So option B is also not correct because it will have an effect. Option C, viscosity of water. So it is the water that is falling down, and the water is not causing the drag. The air is causing the drag, and the water is the object upon which the drag is acting. So the option is C, since it is not causing any drag. So, since density equals to mass by volume, for a constant density and a higher volume, there should be a higher mass. With a higher mass, there would be a higher weight. With the higher weight, there need to be a higher drag. For a higher drag, there should be a high speed or velocity. So option D is also not correct because it has an effect on the terminal velocity of the raindrop. So the answer to this question is C. Number 6. Seashells are protective outer casing of some sea creatures. The shell is left behind when the creature dies, and the shell is moved around on the seabed by the tides and waves. So this is the diagram of the seashell. Shells washed up on the beach are found to be as smooth as when the creature was alive. So when this surface was is smooth as the time when it was alive. This is because the material from which the shell is made is. So the answer is A, hard. It is because the question says that it is as smooth as when the creature was alive. So the shell is hard. So the definition of hard is it resists any indentation on the surface. So if there was any indentation on the surface, it would not have been smooth anymore. It would have been a rough surface. So the answer to this question is A. It is not B because it is not related to the question, since the question asked as smooth. Stiff is basically the resistance to the change of shape. So there is no indication of the change of shape anywhere in the question. It is C. C is strong. Since the shell is strong, it is because the shell did not get destroyed or anything. So it is strong, but is not related to the question because it only refers to smooth. So it is not tough either for the same reason. So the answer to this question is A. Number 7. Four forces act on an athlete running at a constant velocity. So the air resistance is R. So the athlete is running in this direction with an air resistance R. So the air resistance would be here, air resistance, and this is the velocity. There is friction between shoes and ground F. The normal contact force is N and weight is W. So since there is a weight downwards, there should be an equal and opposite force due to Newton's third law upwards, which is N. So the main thing to point out here is constant velocity. So at a constant velocity, the acceleration is not changing. So the velocity is not changing, so the acceleration is zero, since the change in velocity is acceleration. And since the Newton's first law states that F equals to ma, so with a constant mass, if there is zero acceleration, there is zero force, so there would not be any resultant force, so the all the forces will cancel out. So the resistance is in this direction, weight and Newton is in this direction, so the answer could be B or D, but these two are not the answers. The normal reaction force in the could be in this direction, since the leg of the athlete is in this direction, but this does not have any cancelling out effect. All the directions will cancel out because there will not be any resultant force, because this is constant velocity. Option D, these do not cancel out. There is a resultant force in this direction. Although the vertical components cancel out, the horizontal components do not cancel out. Only in D all the components cancel out, so the answer to this question is B. Number 8. A bird flies with a velocity of 4 meters per second through the air, heading due south. So it is heading due south with a velocity of 4 meters per second. Due to the wind, the air is moving at 3 meters per second in a direction from east to west. So from east to west, the direction is 3 meters per second. This is right angle, so the resultant velocity will be this. So the resultant velocity by Pythagoras theorem, hypotenuse square equals to a square plus b square. So this h resultant will be equals to root over of this square plus this square. So 3 square plus 4 square is root over 25, which is 5 meter per second. So the answer to this question is C. Number 9. A ski lift carries skiers along a 450-meter slope that is at an incline of 25 degrees to the horizontal. It can be assumed that the motor has to lift an average additional mass of 80 kg for each skier using the ski lift. So the mass of each person is 80 kg here. Which of the following expressions represent the work done against gravity when lifting an individual skier up the slope? So the work done is basically force into distance, but the work done is being done against gravity. So in an inclined slope like this, if there is theta and there is suppose an object here with a weight mg, there will always be the direction of component parallel to this ramp would be mg cos theta, and this would be mg sin theta. So here we can see that against the gravity it is 450 meters, so the force is mg sin theta against the weight. The gravity is mg and the force is mg sin theta. We also know that work done is equals to force into distance, so the force will be m into g into sin theta into distance. So the force is m is 80 into g is the gravity, which is g, into sin theta. Sin theta, the value of theta here is 25 degrees, so sin 25 into the distance is 450. So we can rearrange it and write as 80 into g into 450 into sin 25. So the answer to this question is B. Number 10. Three identical springs L, M and N are connected as shown. Spring N has a load attached to its lower end, so this is a load and it is attached to the spring N. The extension of spring L is X, so the extension of spring L is X, this is X. So what would be the extension of the springs? So if L is X, the extension of M would also be X, since it is connected in the same way and the weight on it is the same, which is the weight of this bar, which is also dependent on this. So these two are X, so it will be either A, C or D. So this is one length and this is another length. So if a constant load is being pulled by two springs, the extension would be half of that of the one which is pulled by one spring. Since the force acting on one of the springs L and M is being halved, it is because if we imagine that we are lifting a book with two of our hands, the force on each of our hand will be halved and our muscle tissues will extend half. But if we pick up the same book with one hand, the muscle tissue will extend by twice, it will contract by twice, and the force and the tension in our muscle tissues will be doubled. So the tension in this spring is also doubled, and this causes the double extension 2x. So the answer to this question is D. And this is the end of paper. Hi, so if you like the video, consider liking or subscribing. Thank you for watching, guys.